Hello and welcome everybody. Good morning if you're in the Western Hemisphere and good afternoon if you're in the Eastern Hemisphere. I'd like to welcome you all to the second webinar in the Soybean Innovation Lab series of webinars on improving mechanization in sub-Saharan Africa for smallholder farmers. Our first webinar was held on May 3rd and included the International Institute of Tropical Agriculture and Compatible Technology International. That webinar is archived and can be located at the Soybean Innovation Lab website, which you see listed on your screen here. Today, the two speakers are the Malawi Oilseed Sector MOST, Malawi Oilseed Sector Transformation Organization, and the Soybean Innovation Lab. On July 6th, we'll have our third webinar, which is Imara Tech, a startup in Tanzania, and Purdue University. And then on August 2nd, we will have Kleber LLC, which is going to talk about the Agoon tractor. So the reason we're having this webinar series is because, as many of you guys know, agricultural innovation and mechanization in Africa still lags behind other continents. And machinery is a key agricultural input and market enabler for improving agricultural production. Some of the constraints in sub-Saharan Africa for mechanization include affordability, availability, lack of farmer skills, private sector constraints, and gender issues. The format of the webinar today will be the following. Tawera Jelakasi from MOST will give the first presentation. If you have questions for Ms. Jelakasi, you can type them into the question pane, and you can do that as the talk proceeds. Then at the end of the presentations, the questions will be read to the presenter for the answers. And then the same will happen when the Soybean Innovation Lab gives the second presentation. We'll use the same format. We also have 4 poll questions that, so I will present the polls and give you all 1 minute to answer, and then we'll compile the results and give them. And then finally at the end of the webinar, there are 2 exit questions for you all to answer. So now I would like to introduce Tawera Jelakasi from MOST, who will give her presentation. Thank you all for coming.
Okay, thank you. My name is Tawera Jelakasi, and I'm from Malawi Oilseed Sector Transformation. That stands for MOST. As a program, we are looking at oilseeds in Malawi market systems, including soybean, groundnuts, cotton, sunflower, and sesame. I'm the intervention manager responsible for soybean. And one of the interventions that we have been looking at is the soya thresher. So I'll share with you the experiences we've had as far as the commercialization of soybean is concerned. So on the screen, there's a soya thresher that was designed with support from MOST to really look at how smallholder farmers can access the threshing through mechanization so that they are able to improve, first of all, on their yields, but they are also able to reduce on their costs. So I'll give you a bit of a background about soybean in Malawi. In terms of production at the moment, we have about 153 hectares of soybean production, and the potential yield, if you just look at that, should be over 500,000 metric tons. But apparently 90% of the soybean in Malawi is produced by smallholder farmers, achieving on average about 1.2 metric tons per hectare. And in terms of land allocated to soybean, the smallholder farmers would allocate between 0.2 or 0.4 of a hectare. So as Malawi Oilseed Sector Transformation, when we did our analysis of the soya sector, the analysis showed that there was lack in terms of the smallholders, in terms of their margin when they are using manual labor. And we identified 2 factors for that, to contribute to that. First of all, it was the cost of hand threshing itself, mostly done by women and children. But also we discovered that there's a lot of soybean that is lost when people are using manual threshing, about 10% of the soybean. Okay, so because of that, we also discovered that a lot of people are not really investing in the production of soybean because of the constraint that they are having in as far as threshing manually of soybean is concerned. So we looked at what would change if we introduced mechanized soya threshing among the smallholders in Malawi. And generally, on the 0.4 hectare of land, the smallholders can get about 400 kgs. And the average selling price of soya at the moment, it's about 35 cents. And the current income, it's about $140 for a smallholder farmer. And the cost of manual threshing per kg is about 0.07 cents, which accumulates to about $28 when they are using the manual threshing. And the net income to the farmer, it's about $112. But once this is mechanized, we saw that there was a very big difference. So when you look at the presentation, you see that the farmer would get 400 kgs normally, but because now they are using mechanized threshing, there's an additional of 40 kgs of soya that they would get. And at the same average price, you will see that the net income is increased to 152. And the cost of shelling per kg is about 0.05 cents, which gives the farmer the cost of all the manual labor to about $22. But when you compare the two, the net income to the farmer when he is doing manual threshing is less when compared to the farmer when he is doing mechanized threshing. So with support from MOST as an intervention, we looked at a manufacturer who was willing to pilot manufacturing of two threshers, one diesel operated and the other electric operated, and placed them with entrepreneurs to provide threshing services to smallholder farmers. And the evaluation came out with two recommendations. On the picture there, you can see a woman standing beside a thresher that was produced initially. But after they had tested that, they came up with two recommendations: is to improve the design of the thresher, because when they were testing out on the market, they were struggling. They discovered that the thresher was struggling to break down soybean stalks, which slowed down the process as the machine needed to be open to remove stalks that were stuck inside. The mouth of the machine was also very narrow, so they were getting very small quantities of soybean at a time, and therefore it proved to be very time-consuming. The open build of the soybean thresher at that time also caused soybean to spread all over when threshing, and that was adding to the task of gathering all the share, the soya after they have threshed. So the open design also was a safety concern, as it caused some injuries to the operators when they were operating it. So as a program, we took this feedback and we looked at the feedback, and then we decided now to engage an engineer to look at the design and improve it, taking into consideration all the challenges that the smallholder farmers were facing. So the engineer did the design to improve on the thresher, and we have got the manual on the MOST website that anybody else can be able to download and use it to manufacture a soya thresher if they need be. So in phase 2, what we did was to identify yet 2 companies that were able to manufacture the threshers. So each company was tasked to manufacture 3 threshers, and the 6 threshers were placed with 6 entrepreneurs. And this time, what we really wanted to establish was a business model that entrepreneurs can use to provide threshing services to smallholder farmers. So after the phase 2 of the intervention, the evaluation also came up with 2 outcomes. So what you see in the picture is the revised soya threshing machine that the two manufacturers that we had identified were able to produce and place with the smallholder farmers. So when we had put the threshers with the entrepreneurs, we had asked the entrepreneurs to collect specific data that would help to produce a business model that anybody that would want to invest in soya threshing as a business would use that model. But they came up also with some other recommendations after testing the threshers on the market. So in Malawi, the soybean harvest and sales window would normally take about 45 days. This is the time that people would harvest the soya and take it on the market. So it's a process that has to be done very quickly. Now, with the threshers that came on the market, the entrepreneurs discovered that the speed of the threshers was not fast enough because they needed to service one smallholder or a number of smallholders in a day so that they can be able to service more within the period that people are harvesting. Where people had booked the entrepreneur to say that we want you to come and do the threshing for our soya, if the entrepreneur was taking long because he was providing service to another smallholder, the smallholders would then turn back to the manual threshing because they would want to thresh their soya as quickly as they can. So the entrepreneurs came with also other modification suggestions and modifications to the thresher. So they suggested that the mouth of the thresher should be made more wider so that they can push more volumes of soya in a given time so that they're able to serve more farmers and at the same time reduce the cost of threshing per kg. To them, they would want to maximize on the profit, but we're also looking at it that if they're able to charge a smallholder farmer a reduced fee for the threshing, then the smallholder farmer would also benefit for the reduced cost of threshing per kg. So MOST, as we are using a market systems approach, at this stage, what we did, the decision was made now to leave the design of the thresher on open air so that anyone else who would want to manufacture the soya thresher can be able to do that. But the manufacturers have continued to improve on the design of the thresher, and the thresher itself is slowly becoming aware on the market, and people are now becoming aware of the benefits that they can get when they use mechanized threshing as opposed to manual soybean threshing. So that's what I had. But another thing that has really, it's making the commercialization of soybean a big, an important intervention in Malawi is the fact that it is mainly women and children that are involved in the manual threshing of soybean. Now, with the introduction of mechanized threshing, most of the women are appreciating that it's really taking away the burden of manual threshing from them because that is a lot of hard work. But it's also releasing some time that they have time to do other things. The time that they would have spent manually threshing the soya, now they can use that time to do other things. So that's another thing that we are also seeing as an advantage of mechanized threshing. At the same time, when they are doing the manual threshing, they are limited in terms of the amount of soya that they can beat, but at the same time, they can also clean by winnowing. The winnowing is mainly done by women in Malawi. So where the soya is done manually, the women would have limited amount of soya. Normally, they would charge about 500 kwacha, which is about maybe $0.75 for a 50 kg bag. And in a day, if they are using manual threshing, they can thresh about 7 bags. But with the mechanized threshing, they are finding that there is more soya for them to winnow in a day. So in a day, 2 women can winnow about 20 bags of soya, which really gives them a lot of money in terms of income. So that's what I had prepared to share with you. If there are any questions, then you're welcome to ask.
Thank you, Tawera. I have a first question. Does the MOST thresher, does it winnow as well as thresh?
No, it only threshes. It's only a small percentage that you can collect as clean soya as it is threshing, but you have to winnow the soya after threshing. So there's now additional work that you have to do after really threshing it mechanized.
Okay. Also, do you think, like we had some people that came up with a pedal-powered winnower. Do you think that women's winnowing is pretty efficient, or do you think women in Malawi would be receptive to more mechanized winnowing methods?
I think they'll be more receptive to mechanized winnowing methods because the winnowing itself also takes time, and it's not like 100% efficient. Some of the soya is also lost as they are winnowing. But again, when I'm talking about them winnowing about 20 bags in a day, that's something that we'll do from morning up to about 5 o'clock in the evening, maybe 6 hours or 7 hours. So if this process was mechanized, I'm sure a lot of women would be receptive to that.
Okay, it looks like we have some questions coming in from the audience now. Martin Hilme asks, does the increase in income from mechanized threshing enable reinvestment in renting mechanized threshing services and or investing in mechanized threshing?
Come again?
So he's asking, does the increase in income that the women get from engaging in mechanized threshing, does that enable them to reinvest in either hiring a thresher or investing in a thresher themselves, or do they tend to use that money for something else maybe?
No, the women are not the owners of the thresher. Normally the thresher would be owned by a different entrepreneur. The ones that are winnowing, they are just providing the winnowing labor for their own income. So the income that they are getting is not enough for them to be able to invest in a thresher, because at the moment the cost of the thresher itself, it's about $1,000. So for somebody really for women at their level, it would be very difficult for them even to reorganize resources to invest into the thresher. So they'll only be available where somebody is providing the threshing services so that they can offer the winnowing services as part of their income.
Okay, the next question is, what's the weight of the thresher? And then the second part of the question was, what is the fabrication cost? But you just said that was $1,000. So they'd like to know what the weight of the thresher is and how portable it would be.
No, it's very heavy. I think it would take, I wouldn't give the actual weight, but I know that it takes about 4 men to pick it up from the ground and to get it onto a pickup. The heaviest thing on the thresher is the diesel engine. That's the one that is very heavy.
And what's on the cost breakdown, is it about half the cost is the engine, or do you know what the breakdown is on the engine versus the rest of the equipment?
The engine, it's about a quarter of the cost of the whole thresher, yes.
And what's the cost? What is the energy cost?
Come again?
What is the energy cost of running the engine? Is that included in your economic breakdown?
Yes, it is. It would cost, the one that is run on the diesel, when we did the calculation, it was costing about, in Malawi kwacha, it's 3 kwacha per kg. So I think the rate is now 750 Malawi kwacha. I don't have a calculator with me. It's 750 Malawi kwacha to $1. So we can calculate that.
The audience is also wanting to know what price do the entrepreneurs offer the soybean producers for threshing? Do they pay money, or do they pay in crop?
No, they pay money, and the cost is about 0.05 cents per kg.
Okay. And do these threshers move to clients, or do clients come to the thresher?
The threshers will move to the client. Because the original one, the way it was designed, it was very difficult to move it from one place to another. That's why the entrepreneurs opted now for a diesel one other than the electrical one, because the other areas where the threshers go to do not have electricity. So it moves to a client. The clients do not come with their soya thresher to be their soya to be threshed.
Okay. And let's see. Did the data from the entrepreneurs validate the 10% increase in the volume of beans that survived threshing?
Yes, it did. And in other cases, actually, it was more than 10% that they were able to recover using the mechanized compared to the manual threshing.
Okay, the next question is, does MOST identify the entrepreneurs, or do you have individuals or group come to MOST to inquire about purchasing a thresher?
Initially, we identified the entrepreneurs that were providing the services, and after the second year, we've had inquiries from other entrepreneurs that want to invest in the thresher. So our role is just to facilitate them and link them with the manufacturers. So the first 6 were identified by MOST.
Okay, and could you repeat the capacity in kilograms per hour?
It's about 60 kgs per hour.
Okay.
So it was a range in some other areas because we had placed the threshers with a number of entrepreneurs. The highest was 60 kgs an hour. The other one was 50 kgs an hour. The other one was 50 plus kgs an hour.
And about how many farmers can it service in one crop season?
I think at the current rate, the thresher can do in a day. And if we look at the smallholder farmer, at the moment the smallholder farmer would have about 400, so it can only maybe service 2 plus smallholder farmers in a day. That's why the entrepreneurs are suggesting that the design.
Let's see, I have lost Tawara.
2,000 kgs in the day, then it would make economic sense to provide it as a service.
Okay. Okay, let's see. Okay, so if the threshers are heavy, how do you access hilly areas?
Come again?
This person is asking, if the thresher's heavy, what's your suggestion for like getting it up a hill or to a difficult area to go to? Or how are people moving the threshers? Are they moving them on motorcycles or cargo trucks, or how are they moving it from field to field?
Okay, in the rural area, they use ox carts to move the thresher from one area into another. And probably these would be areas that are about 10 to 15 kilometers radius from the farmer to where the entrepreneur would be. The others, who are big commercial farmers, would actually place the soya thresher on a truck, maybe a 1-ton pickup truck. These are commercial farmers that would have over maybe 50 hectares of land, and they would want to thresh the soya. But in the rural areas, they are using the ox carts.
Okay. And does the thresher do much physical damage to the soybean seeds?
Not really. When the first one was really breaking the grain, but when it was improved, the breakage was very minimal.
Okay,
But
and
the
how
quality
about,
of seed itself was very clean.
good. And can it be used for threshing other legumes or other crops?
Yes, it can. It's been tested on sunflower. It has also been tested on pigeon pea. So in Malawi, people can use it to thresh sunflower and also pigeon pea. This is why entrepreneurs are more interested in it, because they can provide the services to smallholder farmers in soya, smallholder farmers in sunflower, as well as smallholder farmers in pigeon pea. And in terms of the calendar of the crop, these are the crops that would come at different times. So soybean would be the first, then sunflower, then pigeon peas will come later.
Okay, and have you guys tried it with maize?
No, we have not tried it with maize.
Okay. And is there a publication or a case study on thresher services in Malawi?
Not a case study. What we have is just some information and data that we have gathered as a program, which some of it is available on our website, but some of it we have shared with the manufacturers so that they can use the information to improve on the design.
And how did you identify the manufacturers, and who are they? Are they like local blacksmiths, or what kind of business? At what kind of level are their businesses?
The initial one, we had identified a local, I would say, blacksmith that did the first soya thresher, and we were able to identify this person because at that time we found that he had developed one thresher that he was using himself for his business, but it was really done in a very crude manner. So when we identified him, we asked him to improve on that soya thresher, which he did, and that's the one we first tested on the market, which when we got feedback on the performance, this is the time when we engaged an expert, an engineer, to redesign it so that any other person can be able to fabricate. So during the phase 2, because we're looking at more production, the blacksmith would not produce more of the equipment. So we're looking at somebody with a capacity that can produce the soya threshers. So we're able to identify some local firms in Malawi that are already doing other fabrications. So the two firms that we had identified are Malawian firms with a capacity to produce a little bit more in terms of number, but also their workshops are a bit more sophisticated compared to the one we had used initially.
Okay, and then the final question is, one of the audience members would like to know if they can get the contact of the manufacturer of the second generation thresher to test elsewhere. So I'll kind of throw an answer in there that we will make Tawara's contact information available to everybody so that you guys can contact MOST and Tawara to talk about, if you want to talk more about their design and their manufacturer, because I'm assuming that the manufacturer might be a little bit hard to contact directly. Also, Tawara did mention earlier that the design is on the MOST website. Tawara, did you have anything else you wanted to comment on there?
Yeah, I think, yeah, if they need the contact, so just say, no, it's easier to contact the manufacturer. We can actually provide the contact details. Yeah, sure.
Okay. So I want to thank you, Tawara, and thank you all for giving your questions, and thank you to Tawara for presenting as well. I'm going to launch one of the poll questions now. We'll see how this works because it's the first time I've done it. So let's see if you all get a poll, if you could answer it. I'm going to close the poll because it looks like people have quit voting. Okay, so you guys can see the answers now. 65% said that we should be targeting service providers, and 65% said farmers groups. Only 25% wanted us to target larger nucleus farmers, and 55% said to target smallholder farmers. Okay, the next question is, What do you think is the most important agricultural mechanization for Africa? Is it threshers, small combines, two-wheeled tractors, four-wheeled tractors, or planters? And unfortunately, those are it only allowed me to choose 5 things. So let's see what you guys think of those 5 things. Okay, and you guys can see that 72% of the people said to focus on threshers, 28% small combines, 67% two-wheeled tractors, 39% four-wheeled tractors, and 61% planters. So thank you guys for doing that poll. And I'm going to move on now to the next presentation, which is me. Give me a second and I will pull it up. All right. Whoops. I just jerked my headphone off. Okay, my name is Kerry Clark. I'm with the Soybean Innovation Lab out of the University of Illinois and the University of Missouri. And I want to talk about thresher development and training in Ghana. So the UN FAO has identified cycles that result from sustainable crop production intensification, where we have higher farm income, cycling with more savings, higher demand for mechanization, and higher productivity. That's mostly driven by the higher farm income, but once we have higher demand for mechanization, we'll end up with higher levels of supply, lower capital costs, and lower operating costs. So to drive the higher farm incomes, we need to look at investment in rural development, establishing social protection systems, building urban-rural linkages, enhanced land husbandry methods, sustainable commercialization of farm products. So as I started working in soybean in Africa, it became pretty apparent quite early on that a lack of mechanization or agricultural technologies was creating a bottleneck in the level of agricultural production. So the Soybean Innovation Lab's objectives include bringing about change in a variety of ways, including recognizing the importance of mechanization and intensifying agricultural production. So we would like to develop new sources of farm machinery that are more suitable for African conditions, while focusing on environmentally sustainable mechanization. So we've decided to start with threshers because, although like in the poll, many of you mentioned that planters are also important, it's going to take a little bit longer to match up conservation agricultural research with new forms of planting mechanization. We also feel that threshers eventually need to address issues of organic matter retention, where the crop residue stays in the field. We're working on sustainable business models, including gender equity, building up public-private partnerships, and increasing in-country capacity development. So the biggest issue as we began to embark on a program of mechanization at the Soybean Innovation Lab was, how do we prevent adding to the equipment graveyard problem? Because if many of you guys who live and work in Africa know that many times equipment gets imported to countries where there is not either parts available or the knowledge on how to fix the equipment. So as we work on mechanization programs, we need to always keep in mind that that we don't want to add to the problem. So one of the things that we came across early on in our project was this women's group in Bulinga, Ghana, who on their own had a blacksmith in a nearby larger town build a soybean thresher that the women helped design and come up with the specifications for. And this thresher was built for a cost of about 700 cedis, which is $250. There's a couple reasons that the thresher was so inexpensive. One, all the metal is fairly thin, probably not quite durable enough, and recycled metal. Many of the parts were recycled. But what this did show us was that there is the capability for local blacksmiths to build threshers, and there was also the desire amongst female soybean growers to use and build and pay for threshers. So that led to our strategy, which is that we want to create designs that can be built, modified, and repaired locally. So in this case, locally is the key thing. So we wanted to start with threshers because of post-harvest loss and the drudgery issues involved with manual threshing, or hand harvest and threshing. We wanted to create a well-functioning prototype, and then we wanted to train local blacksmiths in its production. And then, in addition to training those blacksmiths, we wanted to assist them in building businesses through education and networking. And then we also wanted to field test the designs with local farmers, which we did with existing women's groups. So our first design was geared towards small groups of women, and we built a fairly small thresher, thinking that a smaller thresher would be more affordable for just a few women. Once we got these out into the villages, what we found was that the design was too small for multiple users, too expensive for just a few farmers. It had about $1,000 cost, with the engine being half the cost. We also found that women preferred to hire a male operator, and that male operator needed a larger capacity thresher for him to be profitable as an operator. There was also issues with unfamiliarity with engines and mechanizations, which led to problems with use. So we definitely discovered that not giving proper training, or not extensive enough training in its use, its maintenance, and its repair would lead to the thresher becoming part of the equipment graveyard problem. Most of the users that we experimented with also stated that they thought a multi-crop thresher would be a better thing for their needs. And multi-crop meaning they wanted the thresher to not only be able to do things like cowpea and soybean, but to also do maize. And we were a little bit worried that if the thresher could do maize, that it might become less available to women and more used by men. So we are now doing another experiment where we are producing larger threshers. We have those in production, and then we'll test those with service providers or nucleus farmers as targeted clients. The service providers would still be around a group of a women's group. So we're working with village savings and loan associations, existing groups, to keep women as potential owners of threshers. In Ghana, we're also working with an NGO called MEDA, which has developed a network of female growers as certified seed producers. So these women now, because they have commercial business in soybean production, are excellent targets for becoming potential thresher clients. And then, of course, utilization and maintenance training is going to be paramount in anything we do in the future. So the other part of our project, in addition to developing designs and prototypes with field testing, is that we also are doing training. So we created a blacksmith fabrication and business development training program in 2016. So already blacksmiths that were already in operation were identified by NGOs and extension officials in the country of Ghana. 2 of them had previously been building threshers, but the others were all new to threshers, and all of them had been doing donkey plows, which was about their only agricultural experience. So we trained 12 blacksmiths from 3 regions in Ghana. The training was funded by a collaboration of several different groups, including the Soybean Innovation Lab, IFDC's ATT program, and ACDI VOCA's advanced program, along with Catholic Relief Services. We did an 8-day training with production of 3 prototypes. So the cost of the training was $7,000. It included all meals, lodging for the 12 blacksmiths, in addition to about another 6 or 7 people at the training facility, and then also included renting a training facility, electric energy costs, that kind of thing, for running 3 welders. In addition to that, attendees were also provided seed money at the end of the training so that they could go home and build a thresher that they could then sell and start getting their thresher cells off, get going. So we found that the thresher training was extremely successful. We have done some follow-up with these blacksmiths, and all of them were building threshers. Some of them have changed the design. Some of them have increase the capacity of the threshers. So we are now seeking funding for additional training so that we can get additional blacksmiths building threshers. You can see in the bottom picture, that was the 3 prototypes that were built. So one is actually, 2 are engine powered and 1 was actually bicycle powered. Once they went out to the 3 villages, it was determined by the users that the bicycle powered was not a preferred form of a thresher, that even the poorest of the poor women in a certain village were targeted with the bicycle thresher, and they said even though finances were very limited to them, they would still prefer to have an engine-powered thresher. So as I said, we are kind of in the midst of changing our design. Once we have a final design that will become available on our website, will be an open source design that anybody will be welcome to use and to modify as needed. So what we found as we started working in mechanization, that there's also efforts in mechanization at other NGOs, governmental workshops, and academic institutions across sub-Saharan Africa. For instance, in Ghana, there is the Kwame Nkrumah Institute of Science and Technology in Kumasi, which has students working on design and field testing. The Gratis Foundation has equipment that is needed for building things like pulleys, bending for cylinders. So that's formerly a government program that makes heavy and expensive equipment available to local blacksmiths. And then we found places like the Tamale Implement Factory, which is what hosted our training, where there are small enterprises that are working on equipment design and fabrication. Additionally, there's a large collective of local artisans and welders who are working in agricultural mechanization. And I don't think this is just true in Ghana. I think this is probably true all over sub-Saharan Africa, because we have had people, as we publicize our mechanization program, we have had people say, we'd like to buy one of your threshers and move it to Kenya or Ivory Coast or various places. And I feel that what would be best done is that we train people in your areas to build these threshers rather than importing them from one place to the other, because we do need trained thresher fabricators and repair people all over sub-Saharan Africa to make these thresher programs viable and to keep these threshers from ending up in equipment graveyards. So a lot of the young people that we had found that were already working in agricultural mechanization and building threshers were reverse engineering these designs from locally available imports. Availability of materials could be very limiting in some places. In the top corner, I don't know if you guys can see my mouse, but in the top corner you see an orange thresher there. That is a locally built thresher from a blacksmith who could not get raw materials in his village. So basically he pieced together used metal. But what we have found is that sometimes a copied design is missing an integral design factor. So, and that may prevent it from not working quite as well as it should. For instance, a copied design may not retain the grain very well. It may shoot grain out the exit and entry chutes. So there's various things that can go wrong. And so having organizations like the ones that are presenting at this webinar series build these designs and field test them will help make these local blacksmiths more successful and make the machines more popular with farmers, because we'll know for sure if they actually work or not. So here's some of the blacksmiths that we've been working with in Ghana, and all of these guys have modified the designs according to their farmer needs. And you can see the green thresher here in the bottom right corner is the design that we're moving more towards now, as we move from thinking about very small groups of people to service providers or larger farmer groups. So our future work is we would like to bring together designers, field testers, service providers, fabricators, and farmers so that we can get designs that can be commercialized that are high functioning and locally repairable. And we feel that every voice needs to be heard in this process. That if we leave out even one thing, that we won't end up with a product that will be widely accepted. And then I would say we need to train in commercialization, fabrication, utilization, maintenance, and repair. So the more training we can give, the better, because as we experienced when we sent our 3 prototypes into the villages, that even though we gave some advanced training on the utilization and maintenance and repair, that when the machine actually did break, that it was not fixed by the people who were operating it. So additional training and confidence building is important to get these machines out and working. The Soybean Innovation Lab is also interested in collaborating with anybody else who is working in mechanization, because we would like to increase the number of technologies available. So we'd like to branch out from training in just threshers to planters, perhaps fabrication of 2-wheel or 4-wheel tractors. And then finally, we always need to make sure that the needs of the women farmers are addressed. On commercialization, private-public partnerships are going to be very important, I believe, to the success of mechanization in Africa. So for commercialization, first and foremost, we need a good product, and to get a good product, we must field test. So we have heard stories about, so like an NGO might go in and ask a local fabrication company to build a thresher or another type of mechanization, and they might build 50 or 100 of these, send them out to villages without field testing the first one. So field testing is going to be very, very important. And then if you're going to commercialize, we have to be able to guarantee ample supply. So we're going to need privatization and investment of the fabrication process and industrialization of the fabrication. And with that, we'll get quality and cost control, where we have standardization and then collaborations involving parts manufacturers and final end product fabricators. We'll need to grow customer demand for good commercialization. So that's where the the private enterprises might come into play here, where we present these new mech at field days. Extension can demo them, that we put them on demo farms, but the public and the private are going to have to work together to get the knowledge and the familiarity out to growers. And then finally, one of the things that made agriculture great in the United States, where I am, is the availability of credit, and so that a farmer can buy inputs and can buy mechanization. And that's one of the problems in sub-Saharan Africa, is that it is a little harder to find credit. So we need to think then, as we develop mechanization, what are some new models of credit? Can we look at cross-industry cooperation? At our next webinar series at Amara Tech, they're working with the solar industry. Then the solar providers are actually providing credit for farmers that want to buy agricultural inputs, because the solar people see that the two things are actually tied together, because as you increase farm income, you can increase use of solar and solar investment. And then we need to look at ways that we invest in dealers and the industrial part of the mechanization process, so that perhaps they can also be involved with the credit aspects. So questions that I have that perhaps this audience can help answer is, do we need to reinvent the wheel, or has it already been invented? Can we use older Western technology in Africa? The thresher has been around since the 1700s. Small combines, were used in the United States in the 30s. So a lot of designs exist out there. Now, can we go back and use those old designs, or do we need something completely new? Can technology be simpler and smaller? So do we need 4-wheel tractors, or will 2-wheel tractors do? Or is the expense too high for the 2-wheel tractor compared to how many people can use it in a day? So these are questions that I think that I'd like to, this whole mechanization community work on together and try to figure out. One of the things that I've seen is that technology must reduce the workload, and sometimes we assume that because it's mechanized or higher tech, that it's going to make workload less, but that doesn't necessarily make that true. For instance, I watched a demonstration of some women hand pushing a planter across a field, and I could see that it was very slow and awkward for them, and it made me wonder, is it actually more efficient than just the hand planting that they were doing? So in that case, I felt like if they pulled the planter, it would be more efficient. But when you push and you meet the resistance of the soil, it makes it more difficult. So we must always think about how our technology is actually affecting people's workload. And then our technology must address environmental concerns. For instance, if we're doing threshers and people are pulling the crop out of the field and bringing it to a thresher at the edge of the field, we're not retaining organic matter. So like in the United States, we have nearly every farm has a combine harvester, and so is that something we need to think about? Is small combine harvesters going to be necessary for keeping residue in the field, or can a thresher answer that question? So finally, the Soybean Innovation Lab would like to partner with other organizations to address these issues, to address the issue of minimal access to affordable and useful mechanization that stifles agricultural intensification. Finally, we're developing Mechanization Network, where groups and individuals working on ag tech can interact and share ideas and designs, and that's going to be part of your exit questions if you would like to join that our Mechanization Network, so that we can keep the dialogue going amongst groups that are working on this, know how the field testing is working out, know how each different design is affecting costs and benefits to farmers. So if you would like to be added to that network, you can either answer yes on the question, or you can contact me at the following address. And so I want to again publicize that our next webinar will be July 6th. It will be Amara Tech, which is a startup operating in Tanzania, and with Purdue University, who have built a multi-crop thresher for use in sub-Saharan Africa. And then the August 2nd webinar is going to be on this tractor called the Ogun tractor, or Ogun tractor, which is an open source design based on a power platform that can be modified for other uses, such as a small truck or perhaps even a small combine. So I hope you guys all join us for those two webinars. And if anybody here would like to present in our webinar series, please contact me. Okay, now I'm going to go to the questions. Okay, here we have a comment. We have several comments. One is that joint ownership of machinery has been fully discredited 50 years ago. The service life is less than half design life. So I think that is why, I know at SIL, and I think I heard Tawera say the same thing at MOST, is that we've started to focus more on operators or service providers, so that you do have somebody that is in charge of the maintenance and repair. Another comment, maize threshers are very different in design from legume or small grain crop threshers. So there are several companies are doing multi-crop threshers. So if anybody was on the webinar last week, IITA presented a multi-crop thresher which does both small grains and maize. But in general, yes, you get better designs if you can separate the two crops. Tawera, did you have any comments on, did your clients feel like they wanted to be able to have a multi-crop thresher, or were they fine with just a legume or small grain thresher?
No, I think because we are targeting more the farmers that are engaged largely in the legumes, they did not request for the thresher to do the maize. But in Malawi, we do also have the threshers for maize that are already available, and people are providing the services using the similar approach that we are trying to promote. So in the areas where we had gone with the threshers, people are aware of the maize threshers and they are already existing in the area. So we did not have that request because that technology is already available. So actually the entrepreneurs that are providing the threshing services, 2 of them already own the maize thresher, and they are providing the maize threshing services. So that was an additional service that they can provide in the community.
Okay. And then we have a question about the highest threshing capacity achieved in Ghana. And are there any open source designs from the work in Ghana? So our threshing capacity on the small thresher that we started out with is about the same as what Tawera said. So it would service about 2 growers or 2 acres or maybe about 1 hectare a day. That's why we felt it was a little bit too small, and so we're now working on a larger design. The larger design, if I remember right, does about I want to say 300 kilograms a day, but I can't really remember. But it was the one that has been tested so far had enough capacity that it was making farmers pretty happy. Okay, about the open source designs. So our designs will be open source as soon as they're done, but we're still field testing. So I don't want to put designs out there that I don't feel confident yet that will work completely as farmers need them. There are, if any of you guys were on the webinar last week, IITA spoke, and they also have an open source design that is very similar to the one we've been building in Ghana. And so if you are interested in that design, they don't have it posted on a website, but I can get you the contact information for the IITA MEC division, and so you can talk to them about accessing that. We have a comment. Yes, we can use old technology as long as we get parts manufacturing back online. It may make sense to use that knowledge to design more appropriate and low-cost technologies. And that's kind of how I felt that that in order to get parts, we need to have technology designed around what a country is capable of doing in terms of manufacturing or importing parts. We found in Ghana that nearly every part that we needed could be manufactured there. It's not necessarily being manufactured now, but we saw the capability to do it in these Gratis Foundation MEC workshops that they had around the country. Okay, if there's no other questions now, then I'm going to run the last 2 polls. So the next question is, should animal traction be a focus of our work in mechanization, or should it be, should we focus on small engines, or should we look at both? And I'll leave this up a little while so everybody can vote. And it looks like it's ran about half-half, that we should focus on small engines and both animal traction and small engines. So there was another comment that came in. A couple more comments have come in. Austin Leifers with the Clinton Foundation in Cote d'Ivoire said that farmers there are still using mechanical 4-row planters from the 1980s. So what happens is when the part breaks, they take it to a local blacksmith and they copy it. So the planters are very simple, and he says that I think that's why they keep working. So he makes a good point that we can use old technology as long as that old technology is simple enough and doesn't have so many unnecessary parts that it can't be repaired. So as long as we can repair it, we could probably use it. Another comment came in that you mentioned that most farmers preferred the motorized threshing version compared to the hand-powered version, especially poor women farmers. How do you differentiate between their feedback and realistic conditions of implementation for sustainable adoption? I think the only thing I guess the comment I would make there is that the idea was we worked with a program called Resiliency in Northern Ghana, which focuses on the poorest of the poor women, and they felt that these women would not have money to to buy fuel for a gasoline engine or a diesel engine, and that it needed to be bicycle powered. But what ended up actually happening was that that women paid, not in money but in a share of the crop, for the operator, who was male, to ride the bicycle. So what we found was that none of them were actually willing to ride the bicycle. Now, is that realistic that they would be able to use it and pay for it? They stated that they already are doing that for their grinding of their flour, so that yes, they would also be willing to part with a share of the crop for the threshing of the crop. Okay, and now the last poll question is, what do you think is the biggest limiting factor to increased mechanization in sub-Saharan Africa? Is it a lack of credit for purchases? Is it lack of affordable equipment, lack of farmer knowledge, bad design of available equipment, or low farm productivity? And I'll give you guys a minute to vote on that poll. Okay, let me close that one out and share it. So it looked like about 40 people said they felt that it was a lack of affordable equipment, 27% lack of credit, 13% for both lack of farmer knowledge and low farm productivity, and only 7% felt there was bad design of available equipment. So I would like to thank you guys all for participating in the polls. It helps us kind of think about where we need to go. Your hearing about your own experiences is also very helpful. I also invite any of you that have appropriate material to participate in the webinar as a presenter. We're setting up webinars now for fall. And I want to thank Tawera again for presenting the MOST thresher. And thank you all for participating. And if anybody has any other comments or questions or anything that they would like to, they can email me at the email address that I provided earlier. So we were recording this webinar, and it will be available on the Soybean Innovation Lab website, and we will send you an email with that link. So again, thank you all for participating.